take a look at an SAT math question. Now, this question deals with simultaneous equations. Students may know these from school as a systems of equations, but it basically says we have two equations, which you can see here, equation one and equation two, and they each have two variables in them. Now, in this case, these equations also happen to be inequalities because we have the less than and we have the greater than. Now, what makes this question particularly challenging is students tend to rely on approaches that they learned in school in terms of how to best deal with this. But when we have our inequalities going in opposite directions, they're not quite sure what to do in terms of trying to set these equal to each other, work on elimination or substitution or whatever it might be. In this case, we have to remember that we also have multiple choice options that we can choose from. Now, again, not all SAT questions are multiple choice when it comes to the math. There are some where the students have to come up with the answer on their own, but when we're given those options, we want to use those options to our benefit. So it's important to remember in this point notation that the first number in our point is representing our x, and the second number is representing our y. And my job is to determine which one of these solutions is true to both of these inequalities at the same time. So the first thing I'm going to do is I'm going to work with my easier answers. My easier answers say that it's possible for x to be 0. So I'm going to plug in that x equal to 0 in my first equation and see what happens when I do that. I'm going to ignore that y for just a minute, but let me show you why. So we're going to say y is less than or equal to 0 plus 9, which is really saying y is less than or equal to 9. So when I'm looking at answer choice B and C, I'm going to realize that C does not work in this case because 12 is not less than or equal to 9. So I've eliminated one answer choice so far. So now let's see if 0, negative 12 works in my second equation. So I'm going to plug that into my purple one. And we'd say negative 12 is greater than or equal to negative 3 times 0 minus 2. So that says negative 12 is greater than or equal to 0 minus 2, which says negative 12 is greater than or equal to negative 2. Now that is false because we're going to recognize that negative 2 is bigger than negative 12. Now again, it's so important that students not lose track of their signs because if they came down to 2 and 12 here, then they'd be led to choosing the wrong answer choice. All right, so now I need to do a little bit more work and I'm going to go ahead and I'm going to work with 0 as my y value because that's what I can see happening with answer choice A and answer choice D. So let's go ahead and let's try answer choice D. And I like answer choice D better than A because there's not a negative I have to keep track of. So I'm going to go ahead and plug in answer choice D to my first equation. And that would tell me that 0 is less than or equal to 12 plus 9. So 0 is less than or equal to 21. Well, that is indeed true. So that works with my blue equation. Now I'm going to try plugging in answer choice D to my second equation, to my purple one. So remember here, our y is 0 and our 12 relates to our x. So I would say 0 is greater than or equal to negative 3 times 12 minus 2. So I get 0 greater than or equal to negative 36 minus 2. 0 is greater than or equal to negative 38, which is indeed true. Since that is true for both equations, I do not need to work answer choice A. Now, again, this saves students time by giving them simple numbers to work with, addition, subtraction, multiplication. We got to ignore trying to work with the two equations at the same time by paying attention to our answers. Thanks for joining me. We'll see you soon.